Good evening, all. Good evening. Welcome again, dear engineers, my dear friends. Welcome to Construction Philosophy's online program on QA versus QC. I trust that all of you are doing great and in good health. Construction Philosophy is a construction industry magazine which is published from Kochi. We are a year-old magazine published with an intention of disseminating new knowledge and advancements within the industry. In the past 1 year, we have published about 10 issues focusing on various topics such as sustainable engineering, geotechnical engineering, roads and highways, bridges, viaducts, demolition, value engineering, digitization in construction, etc. As the pandemic has restrained us from usual printing activities, we have started conducting online programs and flash courses for the civil engineering professionals for upscaling the knowledge domain. Well, the purpose of today's session is to deliver an insight about the differences between quality assurance, QA, versus quality control, QC. Quality, as John Ruskin cited, is no way an accident. It is the end result of endless efforts. Quality of something that we produce is established on the quality of our own personal ideas and actions. Our mission right here is to bring in the civil engineers of this country on a single podium, the place where we can talk about the happenings within the industry. The country wants first-class engineers to construct next-generation infrastructure. Let us change our views for making it a reality. I just wanted to point out the recent incidences, the recent incidences of failures of structures exposes our way of construction. Yesterday, the Supreme Court issued a verdict permitting the Kerala state authorities to demolish a bridge in Cochin, which was built 2 years ago. Now look at the age of the structure. A bridge failed in 2 years. The Honorable Supreme Court refused to consider a law test before deconstruction. Indeed, the court usually looks into the information and facts furnished by the parties involved. But here, the decision have challenged the total construction professionals and the construction industry. How do a structure fails in 2 years is the biggest question here. A bridge designed by a well-skilled structural consultant in South India, built by a well-established contractor with an excellent track records, monitored by a government-managed consultant. Where did we went wrong? Various civil engineering associations and contractors forums have approached the High Court in opposition to the state move to demolish the structure. But unfortunately, the engineers' voice still stays unheard. This can take place again in our country as long as there is no legal clause for forestall corruption in engineering sector. That's a fact. Corruption doesn't simply mean taking money. If you don't stand up and say no when required, is also corruption. That is my point today. We have a group of engineers who regularly take part in our all events. In this session also, there are a good number of them, and there are new additions too. So welcome all of you to the Construction Philosophy family. We have constantly tried to carry fantastic discussions during our sessions, and the skilled experts in this team, in this group, makes our dialogue genuinely mind-blowing, and every attendee who sticks on until the end of the session would have a lot of takeaways. Trust me. We have observed that quite a number of participants have left the classes early, but believe me, the most fascinating component of the event is in the last 30 to 45 minutes when we begin our open discussions where every one of you would get a possibility to step in and provide your views on a question. Also, I would like to point out that the participants of our events will be added to our WhatsApp groups and Telegram groups for further communications. Your technical interactions are possible in our groups, and our groups are intended to assist each other in terms of technical doubts, jobs, etc. Sharing. Anybody who doesn't desire to be part of it will have all the liberty to exit the group at any point of time. On behalf of Construction Philosophy magazine and on behalf of the whole group, I would welcome all of you to the session. Today again we have with us Engineer Varghese A.Johns, who is a General Manager for Operations and Group Head for Education and Improvement of Dubai Metal Industries Limited. He graduated in Civil Engineering from Motilal Nehru Regional Engineering College, Allahabad, UP in 1980, and a Fellow in the Institution of Engineers India, member, American Society of Civil Engineers, ASCE, also registered professional and chartered engineer, India. Mr. Varghese has around 40 years of experience, professional experience in civil and structural design, technical and project management with consultants, EPC companies, structural steel EPC companies in the Middle East and Singapore for oil and gas industrial, commercial and residential projects. And he has experience in working with engineering consultants for Aramco, Saudi, employed by oil and gas companies, ADNOC Abu Dhabi and Dolphin Energy Qatar, and EPC company Rotary Engineering Limited, Singapore as engineering director. He is currently working as General Manager Operations and Group Head Training and Development with Dubai Metal Industries Limited, Sharjah, UAE, engaged in EPC projects for special steel and architecture structures. Prior to that, with structural consultant Geostructurals Private Limited, which is in Qaqc, as Vice President, Technical, associated with Smart City, KMRL, and other projects. On behalf of Construction Philosophy Magazine and all the participants, I welcome Engineer Mr. Varghese A.Johns to the session. Welcome all. Welcome, sir.
Thank you, Nibu, for the wonderful introduction. And then we held one session earlier, and this is the second session we are starting. The main subject is quality, because we are now reached to a situation that, especially in India, I would say, how much quality we are doing, how much we are actually giving quality in our profession. That is actually a lot of damages because of ignorance or maybe proper implementation or other things, which is we are suffering. As we mentioned, a bridge, a flyover is actually disastrously. I also saw that Supreme Court order, which we could have actually used the residual life of the structure until before demolishing it. But where we went wrong, it is still a big question mark. And the quality is suffered either in design or in construction or in overall or in the material, wherever. So it is a very, very important and subject or a topic, quality, and I think all civil engineers should take lead in practicing the profession with all the areas implementing quality. So it's always we listen to this terminology like quality assurance and quality control. So we actually, most of the time, we are confused. Many people are confused that what is quality assurance and what is quality control and how it is implemented. So it's many people even working in the department quality also has got very little idea unless and until they practice honestly to learn first before they practice it. So then quality means it is not an accident, but it is the result of intelligent efforts. Because it just like that, quality doesn't happen. I mean, lot of investment, like sometimes we say it is the result of investment, intellectual investment, because investment in the sense there's a lot of money is as a source. We invest and produce something from nothing to something. That is a project. So then that project, how it should be done. So the intelligent effort is very much required in terms of engineering knowledge, construction knowledge, material knowledge, and so on. So it's always defined in such a way that it's always an intelligent effort rather than an accident. That is the terminology what we say. In a quantitative term, this slide I have actually shown last time also, just to remind everybody. I'm just showing it again, that quantitative term Q is equal to P by E. Quality means performance over expectations. So that is something which we always we can have a mathematical model or maybe something like that. It is always defined like this way. So Q is more than one means better quality because your performance is always better, more than the expectation. And the other way, if it is quality is less than one, what quality the customer is not satisfied. And the P and E is actually performance and expectation determined by the organization and the customer. So the transition of QC from TQM, because this is actually a long process, a long time it took QC to TQM. So the QC to TQM means, QC means it started earlier than QA. So it was only defining the product. And QA, when it came to QA, means that is including the process and the product. Then quality management is company, process, and product. This is how QCs to QMS actually started. Because you cannot have a QA and QC if you don't have an organization, a company, and a policy. So the system is actually put in this way. It is all interlinked. The quality planning, which is a quality plan, which is divided into projects as well as enterprise, that is the company. So the QM, quality management prerequisites are already defined. And if you say quality assurance, it is preventing defects. What is the objective of quality assurance? We set standards to eliminate defects. And that who is responsible? The stakeholders, the parties involved in the company and the subcontractors, the material provider, the consultant, whoever is associated with a project or a process or a service is actually responsible for the quality assurance, because we form the quality assurance manual or maybe the requirements. When it comes to quality control, that is the testing activities. The quality plan is prepared already, and then during the quality assurance stage, and quality plan is there, and then your testing activities, that is inspection normally, the product or services, whatever it is. So in the 2015 quality assurance, it is it's not only product, it is services also. So when it comes to an organization or say a project quality management is once an organization or a construction company or a manufacturing company, a project is accepted or awarded, and there is, you can see that half above is actually the client and the management of the quality, how it should go. They will appoint sometimes a third party quality assurance company to do the inspection and auditing time to time in the design stage, and it is supported by another group. It will be another third party, design quality assurance, design quality control, manuals and procedures are already formed that will be given to them. Then it goes to construction release for construction, then construction quality assurance, construction quality control. There also, most of the time, a third party consultant is appointed, a specialist people. Basically, they are more aware of how the quality system is implemented. Then approaches to the quality. There is something we can say there are 5 type of approaches: transcendental approach and product-based approach, user-based approach, production-based approach, and value-based approach. These are the different type of approaches to define quality. So let us see what is transcendent approach. Transcendent approach. Quality is absolute and universally recognizable, because we always talk about quality every day at least 10 times, because it is everywhere quality exists. That is universally recognizable. The quality means when you see something, it is, okay, it's a quality product. The third sense, the sixth sense will give you a kind of clue that this is a quality. And it is common notion used by a layman, because everybody uses it. Every common person is actually used that, okay, it is a quality stuff. There is no subjective judgment and is estimated by looking at the product, because it is not individual judgment, and anything which you cannot just estimate how much quality is this. It's always a comparative comparison between one similar type to another similar type. But you don't need to be educated, or maybe you don't need to be more trained in making a judgment. Then product-based approach. Attributes of a particular product is a specific category. Like if you say that manufacturing a car, so the attributes of a particular product is a specific category. Because it's a car, you look different in different models and different manufacturers. Because it's a car, again, it's a car, but it looks different by different companies. These attributes are accepted as bench of quality by the industry. Even all the models, you can see that the quality is actually there, and each one has got a benchmark of quality of that product. Like you make a house, it is, what is the basic function of a house? It will look different, but the basic functionality and other things are same. So the benchmark for a house is rooms, living room, bedrooms, bathrooms, all that is the benchmark for a house. But it will have a quality difference in different ways. Others in the same industry try to produce close to this quality. The same manufacturer or a builder will make everything same, but it will look different. And that is a quality also is actually maintained in making, but it is looking different, or maybe one quality is different, other quality is different, something like that. So then user-based approach. User-based approach is defined as fitness for use, that we seen last time, that fitness use, what is actually the definition of quality is fitness for purpose or use. So if a quality product is actually always fit for its purpose, that is what basically the definition of quality you can say. And it works. It gives you what you want. It is designed or manufactured for. Viewed from users, it dependent on how well does the product meets needs of the customer. Okay, a customer always want to buy something what he wants, and he will always give you some certain specification requirements, and then he will look at the product or the process, or maybe whatever you say as a end result. As a client, you will see that, oh, I want it this way, that so that I am happy. Viewed from the users and the dependent, how well it does product meets needs of the customer. So the customer always expect that this will serve certain functions, and so that I am happy. Also known as customer-oriented approach. Okay, the same thing can be said that way. Production-based approach, an outcome of engineering or operational excellence, and is measured in terms of quality or conformance. If you are making a product or a house or anything, because the outcome, end of the day, you get some outcome, like you constructed your house or your project. So the operational excellence, if it is good and it is a quality thing, you will say, and it is measured, the quality, or maybe the operational things are measured, and it is a quality or a conformance, conforming to what you wanted, or how it is functioning, how it is operating. The manufacturer has specifications and produces as per the specification. So there is always a specification is set for a process or a product or a construction. So you do it in complying with the specification. That is also an approach of production-based approach. So then value-based approach, values we see it in context of price. Like the same type of thing will not be same price, but people spend money to buy sometimes bigger expensive thing, but they are happy and they feel that it is a quality product. So it's a value-based approach, how you approach the product in terms of value. Quality is satisfactory. It is provide desired performance at an acceptable price. Okay, sometimes people say, I got something for value for the money. So it is a satisfaction for each user, or the owner is going to have it. Customer looks at the total value proposition and not the price alone. So when you want to buy certain things, sometimes you like certain product, but you don't give a priority, or maybe you will sometimes sacrifice or maybe compromise on the price. So that is it's a total value proposition, like, so you buy it, but okay, I don't mind paying for it. So value is equal to benefits over price. That is also the same meaning which we see before the model, like definition as such. Then Qaqc framework elements and manual, because every company, every construction company, Qaqc frameworks include at least 6 elements. The following are the 6 elements you should include in your Qaqc framework. This is a manual created by the company. Every organization will have a kind of manual. So what that manual content, the content of the manual: quality organization and management, the organizational structure of the quality and the management, how you are actually doing what is your plan for implementing quality. So you need an organization, you need a management, documented standards and specifications. So what is actually your reference, your benchmark to do the quality management? That is the standards, and establish the standards as well as specifications. Sometimes the specification might change, but it vary from project to project or product to product. But there has to be a manual which specifies this. Formal qualifications and experience of employees, because for a particular task, like a structural engineer has to be employed for doing structural designs. So you cannot employ an environmental engineer for that. So the right kind of talent has to be put. So you have to document it and say that these are the people going to engage in this particular kind of task or maybe work. So that is always employing the right kind of people with qualification and experience, because you cannot do a task without having enough experience on how it is being done. So that part is actually there, the people with qualifications and experience who are going to do the job. Then formal qualification of subcontractors and suppliers. So who are your approved subcontractors? You need a lot of materials, but who are supplying it? Are they supplying it according to the specifications or your requirement, your need, or it is going to be good, or you have used it? So you pre-qualify the subcontractors in advance, that giving their giving the specifications and requirements, and then previous experience, and suppliers. Components are supplied by various agencies. The similar thing, you apply there, you pre-qualify based on their manufacturer, their systems, and all those things. Documented field inspections, reports, NCRs, and corrective actions. So there could be documented field inspections, because this quality and quality control, what is their function is, they do field inspection, they do office various department inspection. The process is also being inspected using certain set standards and required specifications. So the reports, how you prepare the reports, NCR non-conformity reports, and corrective actions, how you do, what is the strategy for doing your corrective actions if you have an NCR. So all these things are there. Then control and prevention of non-conformance. That is actually what you call a manual is actually created to state, that is a proactive actually thing to prevent non-conformance, that mistakes or errors. So what you can do, because once you do many inspections of a project or a process, that you will know by looking at it, you will see that these are the causes of happening this, so you can prevent it by doing or having some kind of a procedure, set procedure. Okay, don't do it this way, don't do it that way, do it this way, so that you will get what you want. Then each element should have statement, paragraph, and bullet points that define the company standard, because it has to be prepared in such a document which is kept for everybody to read and see that what is the company framework elements of Qaqc and what is the manual company wants, the policy of the company. Then we come to comparing what is quality assurance and quality control. What is the meaning of quality assurance? It's a promise, belief, and confidence. Because you say that quality assurance is actually giving a kind of confidence to the people, or maybe the client or your customer, that we have certain system established that will give it is a promise, and that will improve the confidence of the buyer or the customer. So here in quality control, it is make or run in an order or within the limits. Okay, you have already a promise given, and your quality control people have to run in an order or within the limits what is specified in quality assurance. A positive declaration intended to give confidence. Okay, the same thing. And you are giving a kind of positive declaration that in advance, that these are the things which we are going to give the confidence because of this process or these procedures, which will definitely give a confidence to the buyer or the customer. So here an ability to run something in an orderly way, because quality control is its ability to run within an orderly way, because that is within the parameters specified in quality assurance, you are able to do it. That is what it is mean. So it is an example like what is quality assurance means having a license to drive a car. This is quality assurance, that you have gone for a test and you got a license. But in quality control, having full control while driving the car. See the difference, because that doesn't mean that even if you have the quality assurance, how do you drive the car? Because can you believe, or maybe can you do it, the entire control of the car while driving? So that is the difference, as a small way it is explained. So now the QA versus QC definition. What is actually QA, quality assurance? A part of quality management focused on providing confidence that quality requirement will be fulfilled. A quality management system, that is the basic content, is the same like giving a confidence to the buyer. A part of quality management on fulfilling quality requirements. Here it is fulfilling, and there it is actually telling that these are the things which gives a confidence. And here you have to make sure that that is fulfilled. So it relates how a process is being performed, because quality assurance is a process, defining a process how it should be. And a project is made, or product or project, what are the processes you have to do to achieve or to complete a product or a project. So here it is more the inspection aspect of the product based on the quality management system, what you have actually said in quality assurance. Here it is process, and quality control is inspection, and make sure that you have complied with what you have already established. Then functional definitions. That is all the planned and systematic activities implemented within the quality system that can be demonstrated to provide confidence that a product or service will fulfill requirement for the quality. So overall, you will see that it is fulfilling everything what you have said in the quality assurance manual or system that can be demonstrated to provide that confidence. Here, operational techniques and activities used to fulfill requirements of quality while manufacturing a product. So the techniques, because this is here a process, the other here it is an operational techniques, which is an inspection. And you make sure that what you have said or declared or established is actually being achieved, and you do an inspection so that an operation is actually, the technique of operation is leading to get what is actually spelled in quality assurance confidence quality manual. So it is quality audit here, and here it is inspection. Then evolution of QA versus QC. Quality assurance actually started in 1950. Quality control started in 1920s, because you know what is the importance of 1950 to 1918, 20, like it was the First World War. When the First World War happened, then machines started manufacturing. There are a lot of machineries were required to combat war. So like companies like, so many companies like Ford. Ford was one of the oldest company where it was, you know, we must have seen that the American car company, because they were not doing manufacturing car, they were manufacturing machines, helping the war. Because that time they started and they wanted to check how their products are actually coming out. That's why quality control, but there wasn't any established philosophy that time. It started later. So the quality profession expanded, include the quality assurance and quality audit functions. The functions of the quality assurance, what are the functions you will do inside quality assurance? So following the industrial revolution, the rise in mass production. So basically the quality control is more used in the industrial area, mass production. So mass production, you need to see that you produce the 10 items and you see out of 10 how many are good. So you need a kind of inspection is there required. So that is how it has started long time back. So there is actually a story behind it, and it has actually been inherited by Ford Motor Company. Ford Motor Company, they started manufacturing automobiles just after that, the 1920s or 25 or something like that. So they are the people in the world, you know, established assembly lines. You know what is an assembly line? You know, it is continuously manufacturing similar same item in a conveyor or something like, so that each section will do their part and then it will keep on going, moving. And once the shell starts, the end of the conveyor assembly, you will see a car altogether. They put it. There is a man called Ransom E. Olds. What he has actually done, he did a little experiment. He called 3 people and he asked them to manufacture or maybe make paper clips, and they give the necessary tools to make it. So what you need to do is to cut a piece small and then given a coil of wire, steel wire. So they have to cut a piece and then bend it and then do it. So they 3 people actually, after a couple of days, this man has actually went and asked how many pieces you have made. So they said, okay, 153 people they have made. Then he changed the philosophy. The 3 people, he put it, one for cutting the steel wire, second for bending it, the third for actually making as a hook or something. So 3 people were started doing 3 different activities in a system, like not one man is doing everything. So after a couple of days, he came and checked, they made around 500. So this is where the philosophy has actually evolved. The mass production and assembly lines and specialized, each section people are actually engaged, expert people or maybe task, so that they can do it fast. Similar tasks, they can do it faster than doing everything together. So there is a lot of people who has actually done, they use their intelligence in developing this kind of things. So they're also actually quality control were there to look after the product and other things, because the philosophy has started and the brain started working there. Now the focus on quality assurance. What are the focus on quality assurance? Fundamentally focus on planning and documenting this process to qualify, such as quality plans, inspection plans, and test plans. Like in quality assurance department, if you have experience with a construction company or maybe a manufacturing unit, they prepare a planning and documenting document, which will have quality plans and inspection plans, test plans. What are the inspection should be carried out, which areas you should do inspection, what actually the estimated quality or required quality levels, that is the quality plans will say, then inspection plans, which all areas you will do inspection, and where all you will do test, you will test materials. Because you want to know, because inspection you cannot find what is the quality, the mechanical strength or maybe the chemical strength, you cannot find unless and until you do a test. Like a welding, a process, you need testing. Visual acceptance is not sometimes give you the clear picture. So a quality control here is physically verify the product conforms to this planned agreement. So this is, you have already a quality plan, inspection plan, test plan in quality assurance. And quality control, what you have is physically verify what you have actually defined here by inspection, measurement, and testing. So this is, you make inspection plan and you do measurement and see that it is correct. And then you do testing so that you make sure that your test plan, according to the test plan, you will do the testing. So this is how it is actually being done. So the key activities of quality assurance and quality control: development of quality plan, implementation of quality plan in quality control. Here, development of inspection plan, follow the inspection plan. So you do the activity here. Then development of SOP, standard operating procedures. follow the SOP. You make sure that your report says that you are following the standard SOP set by the quality assurance part. Evaluation of quality system through audits, because you always have, this is actually a brainstorming thing, like you will come up with quality systems, because then from the experience also you keep on auditing it, improving it. Some systems are established, and after doing some inspection you found that there is some problem, so you keep changing it. It has to be audited time to time. Control the quality of products through inspection, so the set standards needs to be seen. Then preparation of documents for QMS, quality management system, in quality assurance, and implementation of QMS as per documentation. So one is the philosophical thing which is developing, and the other it is implementation by practical means. So the objective of quality assurance and quality control, it is prioritize the customer requirement and translate them with the help of engineering team into technical requirements for product development. That is quality function deployed, QFD. What is QFD means? Suppose you want to build a house. You go to an architect and tell him that I need a 3-bedroom house, and I have my budget is this. So this architect will come with a kind of plan and everything, because whatever you told them, that is the definition you gave to an architect, that this is what I want. And he will translate your idea into an engineering concept. It's like it can be a construction, it can be a product, or it can be anything, a process, whatever it is. Whatever the idea has to be converted into an engineering concept is called quality function deployment. It's a big chapter actually. If you go through it, you can see there is a lot to learn about quality function deployment. Then quality control is inspect the technical requirement of a product or services and conform against the specifications to meet the customer requirement. So you have already established what are the customer requirements, and quality control will confirm that this is actually been the requirements is actually being met by measuring, examining, testing to gauge or one or more characteristics. I mean, this is the practical thing, inspection related thing. So you do that. That is the objective. So QA versus QC, what they do. Quality assurance, prevention of quality problems through planned and systematic activities, including documentation. See, in quality system, that is one of the most important thing is documentation. Whatever you feel, whatever you write, whatever you do, it needs to be documented. A documentation is one of the most important part of quality assurance and quality control. Whatever you, so here it is SOP, standard operating practices, that is written and as a manual, you keep it, inspection plan, how you do your inspection, control plan and quality plan. So here what you do is achieve and maintain the quality of product, processes and services using activities and techniques. For example, 100% inspection measurements. Sometimes how do you define that, whether you need 100% inspection? You cannot do, suppose you have done a welding of a tank. You don't normally do 100% inspection. It will take ages to complete it. So you define the quality assurance manual, say that only I need to do 5 to 10%, and then you locate. So that is how, whether you require 100% inspection or partial inspection, depends. So that will give you a kind of the control and quality plan will define it based on an experience earlier. The documentation, that's what I said, documentation references from previous jobs. Then how they do it. Establish a good quality management system and the assessment of its adequacy and conformance audit operation system and the review of the system itself. Product audit, process audit, and system audit. So you continuously doing an audit of the product and your process, how you are making that product, and the system of including everything, so that you do an audit whether it is right or wrong. So that is the quality assurance you will provide. Here, finding and eliminating the cause of quality problem. So once you have the audit, you will know that what are the problems, the causes of quality problem by finding it, and then you want to eliminate it. So for that, you have to do this kind of, so that is, for example, like why analysis. There is something called why analysis, 5 whys, cause and effect diagram, which we have seen last time in 7 tools, cause and effect diagram, that is a fishbone diagram, what is and what is not, etc. So things of this kind, the questions, and when you sit and discuss the all managers or the lead people, then you come up with all these questions regarding the quality problems and how you will, and you have already got a data and you found by doing QC and how you eliminate it. Because quality, elimination, that is another tool is called lean, elimination of errors or defects. So that is another tool. We will have another session later about all those tools. Defect control, that is production potential defects, right from the product development process design. This is because it's a potential defects, like we anticipate some defects at certain point of the operation. Then categorization of defects, like one will have a welding problem, other will have a bending problem, a material problem or straightness problem. So you categorize it and see that whether it is critical, major or minor. Whether minor means you can absorb it, you don't need any rectification. Major means and critical means it will affect very badly your process or maybe your product. Establish a quality system that prevents the occurrence of defects. So that is mainly why you put all these things, to prevent the occurrence of a defect. So that is what basically it is. Determine the acceptance quality level. What is the acceptance quality level? That also we seen in the previous this thing, the Six Sigma, and also we led the mapping of the defects or maybe the variations. In a straight line, we want the variation should not exceed certain limits. So that is the acceptance quality level. So that is used by standard deviation. You can find out and what is the acceptable level based on the quality requirement of that product. So identify the defects and defect sheets through in process inspection. So like the quality control system identifies it. So here it is potential defects. And then sorting of defective parts of 100% inspection. Some products may require you to do a 100% inspection. Suppose you have a damaged concrete column, or maybe 2-3 columns, in maybe one required 100% inspection of your cover, your reinforcement, and all those things. You are spelling out. So, I mean, which one you will sorting out and grouping it. How many you should do preliminary less inspection, say 20% inspection, and another one is 100% you need to do. So implement an inspection plan, which you have already prepared here, escape defective parts, and in final inspection as per acceptance quality level. So it is performance evaluation, a system of evaluating performance, services of the product against a system, standard or specified requirements of customers, evaluation of performance of, see, like it's an example given here, how you evaluate it, evaluation of performance of a tire with a particular car. You have a tire is already on the car. So, and it is running for the last 2 years, 3 years, a number of kilometers. So this will give a kind of data you can use it for evaluating that particular tire is running for, say, 3 years or 50,000 kilometers. That is a kind of evaluation you will do, the quality evaluation. And here it is actually process involved with job management, competence, and performance during the manufacturing of the product or service. Okay, here it is that the tire is actually, while manufacturing, they will check whether it is done according to the design, specifications, and all. So that is a difference between quality assurance and quality control in that particular, because the evaluation gives you or give an idea that if I provide, because maybe you will find some reason to improve the quality of the tire by doing something. So you can do a study. Similarly, it's an example. Similarly, everything you can do with any product, which is actually, you can see that how long it performs without any defect or maybe failure. So that is the performance evaluation you do based on QA and QC. So as a tool of quality, it's a way of management, a complete system to assure the quality of the product or service. It is not only process, but a complete system, including also control. So here it's a process itself. Here it is a management and it's a process. Just measure and determine the quality level of products or services, because you have an inspection procedure. You will see physically, you measure the quality. What is the quality against your benchmark or your template is actually quality assurance established specifications or requirements. So that is the quality assurance part. You see overview, what we can say, it's quality assurance here. Then it's a product. Then it is a proactive thing in quality assurance. Here it is a reactive thing. Then staff function, because management or senior people are producing it. And here it's a line function because it is in the operations, construction, or maybe manufacturing. It's a line function. Then 7 management tools or QC tools, like the one which we have learned before. Last session we have actually did the 7 tools, QC tools, but this is 7 management tools, which is a little different. It's a new one. Here it is 7 QC tools based on quality control, because the 7 QC tools you will use in establishing your studies or establishing your quality assurance system and quality control, how you will find your defects and provide a solution for that. So that is where these tools are used. Prevent the defects, find the defects. Here, prevent it in advance. You say that if you do like this, maybe you will prevent it. Then here in manufacturing, you are finding the defect. How many are defective? Quality audit, walkthrough. Here it is a quality audit you will do for the assurance philosophy. Here it is a walkthrough. You walk around and see and how your quality is working in your system, your process, and your construction, whatever it is. Defining process here. Then here it is testing, because some elements of your manufacturing or thing required testing. Maybe you have to test your reinforcement while you're doing, if you have a doubt, it is to be a third party laboratory is actually being called and do the testing, because many times, you don't have the documentation available. The manufacturer is not given the required, what do you call, chemical or physical characteristics or the grade or all those things. So you do a testing sometimes if it is very critical. Selection of tools, because which tool you will use to implement your quality control, your inspection. That is how the a comparative study, or maybe the as per this. This is how to implement QAQC, which we have seen last time also, the phase 1, phase 2, phase 3, phase 4. The first phase is definition of procedures and tools for quality control. Implementation of procedures and tools. First is the definition, and second is the implementation. Third is the continuous project quality control. So the quality control is not a process which is for a short period. It is a continuous thing. It keeps on happening, because it's a quality continuous, that we will be having a next presentation is continuous improvement, continual improvement, and rapid improvement. That is also part of quality, how you do it. It's never ending. It's always continuous. Then phase 4, continuous improvement of the quality department, because the quality department is always looking at how to improve your qualities, your product, because you cannot just get stagnant there, because you always have a competitor. He is bringing out a better product than what you are doing. So your quality improvement is always a process, and you need to improve all the time, because your competitor will give you a setback if you don't do it. Then how it is, what are the different documents or areas what you are doing inspection during. Procurement, fabrication, and construction. QAQC expediting. Actually, you will expedite what is actually QAQC. Engineering and design control is a QAP, quality assurance plan. Then procurement, material spec control and inspection procedures, checklists. These are all there, and you will develop it. Waste optimization and control. This is waste is actually lean, Six Sigma. There are 8 types of waste that we will do a session later. So how you will optimize this waste actually mean time waste, process waste, effective waste, and so many things. So, and then how you control it. Fabrication, construction, quality assurance and control. So if you have a fabrication factory or a company, then you will have to have a quality assurance plan, fabrication control fit out, because you have a the process of fabrication is actually you have the material, then you have the fabricator who will put according to the drawing everything, and you will check it whether the dimensions are correctly you fit out. Then you go to the welding permanent. Then dimensional correctness and control. You check all the dimensions in the basis of drawings and specification. The right kind of material is used, the right kind of welding procedures are met. You don't have any, so that is what a process will do. Like welders and welding procedure certification, you will not allow some normal welders. It is certified welders in different levels, 1G to 6G, there are certification levels are there, 1G, 2G, 3G, like that. So non-destructive testing, NDT, you must have heard about this. There are many ways, like we have, how those damage, the flyovers, the IIT Madras and other agencies has conducted studies. See, this is using non-destructive testing methods. There are so many non-destructive testing procedures are there. This is bridge NDT testing procedures mainly established by railways. India is railways. There are very advanced level of resonance kind of thing, because electrical signals are being passed through reinforcement and see that their integrity is good. So there is a lot of NDT procedures are now to study. This is a very difficult thing to study a damaged column or concrete section. What is the condition of the reinforcement inside? It's very difficult to find, and you do sometimes a core test. It's also an NDT. and study the carbon ingress or maybe the quality of concrete after so long, things like that. Surface preparation, paint and coating testing. So how you protect your material by surface, that is cleaning, or maybe sandblasting. That process is used for steel to sandblast and make it clean, and then you painting and coating and testing what is the thickness of the coating, dry film thickness and things. You have tools are there. So how it is there, you logistic control, how you transport things, site erection procedures and quality control. So you have a method statement explaining how you do your work at site, whether it is acceptable or it is going to give you a certain level of quality, and the quality control when you do it site activities. You see in commissioning, because machine like installing a pump or something like, because this you have to a motor, water pump, a huge pump or a generator. So you bring it and then you commission it and see that whether it is according to the specification, your requirement, the problem, there is no problem in the operations. So that is the kind of then operation and maintenance manual. You give how to operate it and how periodically, how you do the, what are the maintenance you will do. Those who are, that there is a manual is actually given by every car when you buy it. When you want to take it to maintenance or maybe servicing, what you will check, all those things. So these are the kind of inspection in this sort of construction areas or maybe manufacturing or products. So this is the human resources, how will you do a quality control. So if you want to hire somebody, you should have a job description, candidate selection, probation reviews, and then performance evaluation, promotion, remunerations and things, 6-monthly interactive performance evaluation, recognition, feedback and advancement. These are all procedures established by each company based on ISO. There is a lot of guidelines. So it varies from time, but in content as a basis, are same. So in sales and marketing, SAD versus quality thinking, dimension of, it is like SAD thinking. A sales department or a marketing department always say, how much money can I make off this deal? You got a job, you signed a contract, immediately the sales people think about how much money will come in. But that is not the way it should be. The quality thinking is, when you have a job, it will be, what is the lifetime value of my customer? I'm going to get repeated orders. How long this customer is going to be with me? So that is the quality thinking. If you do a bad job, you cannot keep him lifelong, or maybe the repeated order will not come. So that is the way it should be thinking in sales and marketing. The objective of the sales department of an organization should think in that way. The estimation and costing. So this is one of the biggest prioritized areas of an organization, how you keep quality control in estimation and costing. See, in estimation and costing, you always need resources. You start putting cost on resources. So you have to plan the resource organizational structure, who are all going to be there, a project manager, project engineers, and so many people will be there required to run a project. So this is resources planning, with people, equipment. You need equipment, materials needed for the project completion. So this is the resources what you will do. Then cost estimation. Develop an estimation of overall cost resources needed to complete the project. So based on the resources allocation, people, equipment, material, and all that thing, and how long and duration also. So you put a cost analysis to find how much it is going to cost. Then Then the other one is cost budgeting, because when you have a job, you have various activities in a project. Like you have to buy material, you have to do engineering, you have to do construction, you have to do your office, HR, administration, quality, and all those departments. And end of the thing, you will see profit. So you have to give certain allocation of budget to each department, each function. So that is called, then you check against the baseline. That is called a baseline. So you put, okay, 50% is I am allocating for the project materials. So you keep controlling it. The project manager's job is to see that how much money, and you will check against the progress of the work and the material, the money consumed, whether that is something which I don't know whether you must be knowing the earned value management. So that we will do later. Earned value management is another technique which you study the project process and see that how you control your project in terms of money and time. So cost control, controlling changes to the project budget, because you cannot keep increasing your budget for each department. That will go beyond your 100% and you are in loss. So how do you manage it? This is how the quality control system, this is called a quality control system for estimation and quality. Then why this actually goes wrong? Then false benchmarking. Your estimation is sometimes, it's not correct. False benchmarking. You think about something old, your assumptions are wrong, and you do it. So that is a false benchmarking. Means you take a price or a cost from a false level, or you don't know exactly how much it is going. You just assume it. And assumptions, man's assumption is another man's opportunity to make money. Definitely, if I make an assumption, and it's another man's opportunity to make money, because if I make a false or a wrong assumption, somebody will make money out of it, benefit. Unclear or incomplete design. So design is one of the major issue when your estimation can go wrong. So that's why everything is a saying that if you do the project on design is correct and your project is successful. So that kind of acronym is there, because people always say that. And then time and the program, your scheduling and planning also sometimes gives you a little bit blow in cost overrun as well as project failure. So these are all elements of quality control and quality assurance, because you have to put your effort in controlling things in the better way, a transparent way, and value-based, knowledge has to be applied. So Qaqc will help in doing that. So the estimation methods are there. So there are a lot of estimation methods. This is different types of estimates people do it. We can start from quality, quick, and dirty to high accuracy and detail. So if you see the graph, there are expert judgment, 3-point estimate, comparative estimate or analogous estimate, parametric estimate, and bottom-up estimate. If you want a very high accurate estimation, then you go for bottom-up estimation. That is based on preliminary design, drawings, and other things, because you already done the first ones are assumptions are made. A 3-point is actually a 3 people or 3 values. You will collect it and take the mean. That is why it is called 3-point estimate, because you must have done so many projects and certain values you take from 3 projects and then you average it. That is a 3.1. So analogous is actually a comparative is called analogous as well. It is the same thing which you use your assumptions as well as the basic drawings. So the accuracy level will improve there. So cost estimation is an important process in project for keeping your quality and other things of better. The cost is calculated based on hunch, but it's from somewhere, it's I have a hunch what this much is the price. So a very good experience, the project manager can give a good clue about, he will have a good hunch about how much it will cost. Otherwise not. This might look fine in the earlier stages of project, but often look unrealistic at later stages. That is what mostly happens. At the beginning, everything is in control. Then later, you overrun your cost, so that you need to do stage by stage auditing. Then quality control in engineering and design, because this is one of the most, I mentioned, the most priority areas, or maybe the maximum attention you should focus on doing engineering and design. So quality related activities performed under engineering assurance standard includes QAP, it is called assurance plan. So the quality assurance plan is actually defined the independent checking of documents, interdisciplinary or interfunction review of documents, and then independent engineering design reviews, because you do design analysis and design first, and then you prepare your documents, drawings and BOQs and things like that. So you have to do the engineering and design reviews, because there you make a lot of assumptions. When you start doing a design, you start with a lot of assumptions. How do you know that your made assumptions are within the limits, or it is working, or it is enough, sufficient, or not? Whether it is guided by the codes and standards, are you verified with it? So somebody has to check it. That's what a review has to be done. Then engineering execution reviews, like always the engineering department will prepare certain engineering execution process that also has to be reviewed. So the selected technical review, scope, design basis, engineering analysis, design, detailing, drawings, BOQ, specifications, and documents. So independent engineering and design review always do this. These are the areas, the design basis, engineering analysis, everywhere. Have you made the right figures you use for doing the analysis? Things like that. Then assure consistent quality in engineering assumptions, drawing presentation, scaling. How do you present your drawing? The drawing has to be checked, your format of the drawing, the content of the drawing, the presentation of the drawing, whether it is readable or the scaling is right or not. And is it in accordance with the design, what is actually design output? You cross-check it. The number of bars or the size of the beam, is it correct as per the design or not? So this is what the inspection or conformity with design output, because you have to be very careful about that. Because normally when you review a drawing, you have to review it in 3 different ways. One is the presentation, one is the information level, because your drawing should have sufficient information for somebody to execute. Because a drawing is issued to the site, and suppose he doesn't have all the information available to execute, some dimensions are missing, he cannot do it. So that cannot happen. That is why this inspection checking is required. So that is information level, and then conformity with the design output. All your size of bars, beams, everything, the design, what is actually provided, the details is in line with your design output, what is shown on the drawing. So completeness of details and component, this is what I was talking about. Consistency with company, client policies and procedures. Always company will have some certain policies how we do it. Design basis, major projects, you will prepare a design basis, includes code standards and good engineering practices. Focus on complex and high risk element of the design scope. Where are the major areas where you should put attention to in designing, because that could be a fatal location for a collapse or a failure. So that has to be understood from the geometry what you receive. Then feasible alternative proposal to optimize the complex details, because if you found something like that, it is not constructible also. You will do a value engineering and constructability review and find out that there is a problem and you cannot do it. Then you will, as an expert, most of the contractors do it. They do an alternative proposal to the client or the consultant that this way you can do it, that is more constructible as well as maintainable and things like that. Formal process documented IDR, this is the engineering. All these things has to be documented in the formal way so that you can retrieve later, even if you are giving a warranty or let's say later if somebody else wants to review it, some problems, you should have a proper documentation of all these things. So then this is another thing, how you check your drawings is color coding, because this is yellow means check prints which are correct with yellow highlighter. Blue highlights with value figures which are not required. Sometimes your drawing will have so many things which is not necessary. So you do it with blue. Then red is actually a correction and changes. You cut it and then you mark it with red, saying that this is not right, you have to change it. And the pink is highlights the values, figures, and parts of check prints, drawings, and documents, which are corrected based on the above documents which pink highlighted, because you have asked them to remove it or correct it. So later you want to make sure that the comments are incorporated. So how do you make sure that this drawing, the current comments are incorporated? So that is where you use pink. So once your drawings are ready, then you take based on all this drawing correction, checking, you keep it in the documentation saying, and then you make the final print. The final print is actually checked. Somebody will check it, supervising lead or head will implement the checker. So it is an independent guy, Qaqc engineer or somebody. Checker in the sense, he will do adequacy, drawing layout, format, requirements, and so on. Then after that, you will put a check print stamp and who is checked by and who is back checked or maybe approved by on the drawing. And then you put the issued for construction, IFC drawing, or issued for good for construction, something like that. You put a stamp and issue it. So these are the process you will do for quality plan, QAP, quality assurance plan for an engineering and design. It is normally a contractor is not doing consultant, or maybe some consultant companies, they have their own engineering, detail engineering says. So you have to make sure that, because a simple mistake, dimensional error can cause a lot of problem at the site. So how you eliminate it? So purchasing and process in procurement, how do you buy materials? Physical description of the materials, like purchasing process, quality control subcontractors, of what are the size, length, width, and other things. You will physical properties of the material. You will give with a data sheet or maybe your purchasing order. Then chemical compositions, you normally like you want to buy reinforcement or steel, what sort of grade you will give, what sort of chemical composition, maybe some other metal you are buying, you are ordering. So what is the chemical composition you are looking for? Then dimensional measurements, tolerances of the materials procured. That is continued performance specifications along with the material supplied, industrial standards about that particular material, because if you're buying steel or cement or something, you can see what is actually the industrial standards about that particular material. Along with you have to get a copy of that for documentation. Then brand name, always sometimes I want something, this cement or that cement, something like you will always mention brand name, that because it is a confidence that will make you tell or maybe advise or maybe recommend by using a brand name. Brand name is actually is achieved or maybe earned by companies over a period of time, their quality and their performance. So everybody knows who are used that this particular brand is good. Then quality control in production construction. Quality is everyone's responsibility. That is how it is said. Deming's philosophy was summarized by the Japanese 1970s. The following A versus B comparison, that is people and organization focus primarily on quality defined by the following ratio. Quality tends to increase and cost fall over time. If you improve your quality over a period of time, the cost will start reducing because no rectification, no repair works, no rejection, that cost is actually being recovered, or maybe that will be a profit revenue for you. And if you focus on cost, cost tend to rise and the quality declines over a period of time. So it is the vice versa, it is like that. And quality is the results of work effort over total cost. This is how production or a construction we will see. Objective of inspection, which is finding out, detect faulty raw materials, detect faulty products, and managers, so that you need to take a decision by finding out once you have an inspection to enable them to discover weaknesses, find where we went wrong, how will you do it, and prevent substandard reaching to the customer and reducing complaints, because you produce something and you have done some substandard kind of work or processes, which will definitely the customer is going to complain about it. And at last, it can say the promote reputation of quality and reliability of product, because it is reliable if a quality is better. Then this is something which I don't want to explain too much. ITP, inspection and test plan, which is prepared by this is more into manufacturing and product manufacturing. And construction also, you have to submit in advance to the client how you are going to do your inspection and test plan. So you prepare something like that. It is a quality control plan. And then you have whole points, and everything is actually defined in this ITP document. So this ITP document is actually defines this way. The activity, tell me what construction activities this ITP document consists of these things. The procedures means tell me what construction procedures I will use. Checkpoints, where all I will check. Sorry. Level of acceptance, what level I can, it's medium, critical or minor or something like that. You categorize it, and DOC verifying document, inspection documents, and inspection by, it's a qualified person did it. Then are there any requirements that needs to be stated, documentation. So that is the ITP, preventive action, corrective actions, and are implemented in response to customer complaints. You have to do a corrective action because the customer complained about your product. So that is, or there is a non-conformity. Then there is a preventive action is actually always you try to, the potential source of non-conformity, you prevent it before going it out, a product. That is what, so to find out the corrective, you can use statistical control SPC. It's that we have seen earlier, the statistics used a lot in this kind of thing to study. And corrective action means what? Action to eliminate the cause and identified non-conformity or other undesirable situation. And correction means eliminate the identified non-conformity. Action to eliminate, that is preventive action, potential cause of an identified unconformity or other undesirable situation. So benefits using quality control in production: increase customer loyalty, gain repeat business, gain new customers from referrals, maintain or improve your position in the market, improve safety, reduce liability risk, contribute to overall positive branding of your product. So that is how it is actually been, the benefits, what you can get. Cost of this thing, cost of achieving good quality, prevention cost, appraisal cost, cost of poor quality, internal failures, which is due to repair works, rework, downtime, things like you have to pay for it if you have a poor quality. External failure because you supplied one material and you get a return that because it is not functioning well, the warranty claims, liability, and it all will lose your business. Quality circle that we last time also mentioned, it is a way of capturing the creative and innovative power that lies within the workforce. This slide, I think you have seen it before. When you want to tell somebody that a worker or maybe somebody who is at the bottom level or supervisor, you just tell them, he will forget after some time. If I see it, I will remember. If I do it, I understand. So you have to force them to make the guy do it. And that is a creative kind of innovative kind of atmosphere you are creating for that particular worker to give you something in return. So it's common purposes and goals, teamwork, and communication, how you communicate. And then common purpose is like a good leader. Sorry, you need a good leader, that guy or a person who is motivating all the people to a common goal. So that is a leader. Like because if you say a manager means a manager is actually administration and he controls it, everything. But a leader is not that. He works with them. He motivates the people to a common goal. Many people together. You have so many followers when you are a leader, not the political leader. Teamwork. So you do it in a team so that you will have better communication you can have by the people, the team who is doing the job. What is a quality policy? Quality policy is actually, you must, like what I said, if you enter an organization, you can see that displayed their quality policy. What is their short document published by the executive management saying that this is our policy. We are going to do this. We are going to stick to ISO 9000, and this is what every problem we are going to attend according to what the policy statement says. Then it is describing your business and your commitment to quality. It is also described there, and it is actually from ISO 9000 2015 clause 5.2. Your vision and mission and core values. What is company's vision and what is company's mission? So you display this and then ask all your employees to memorize it or maybe see it or read so that they know what is the company's objectives, strategies and things. So it's just a funny kind of picture. It's all, quality is everyone's responsibility. Like it's a boat which some people are where it's a leak, they are draining out, and the other people say that, oh, we are not near, but when the boat sinks, all together will sink. The same idea, or maybe the learning is represent that. That is what it is basically. So quality means the person reading this is responsible for quality, because everybody wants to be a quality person or quality things. You want to use it, you want to perform quality work, you perform quality life, everything. So you are responsible for yourself. Whoever is actually looking at this picture themselves are responsible for the quality by themselves. So thank you for a long listening, and now we can see if there is questions.
Okay, sir. So my question is that to have a good product or good quality product, whatever the desired product we are expecting, so whether the quality of material is required, or the erection part is important, or the human or manpower allocated, the skill set is required, which area we need to focus to have the final product.
Okay. See, if you talk about a product, there are three elements. One is the material, one is the process, and one is the human, the one who is actually preparing it, the man or machine. It creates it. So
Right.
you have a certain specification which is also controlled or within the quality system. Your material specifications are defined, so you cannot go a lower quality. That is your requirement. Then your process is also being controlled by different type of what do you call procedures. So the process is actually done through as per the procedures established by the QA department, and the QC is actually checking what they are doing. And if this will help to identify the people, those who are not very expert in doing their task. So this is, see, that is what, there is a area what it is quality circle. Because this is a small group of people, they are always put together with another senior person. So they will try to learn, they will try to, because that person will correct him if he is going wrong. So that is actually a team. It's not one individual is working. 2 or 3 people together is working, is supervisor. And if you find that the mistakes or errors are repeatedly happening, so you have to conduct a kind of training, or maybe you should have a policy to train people. That is one of the major area what companies ignore. They don't teach people. They expect everything should come from, they put somebody there. A man cannot produce like a machine, because he has to use his skill, experience, knowledge. These 3 things has to be there. So for that, the seniors or the departments should put a training that every company nowadays, every company spend at least, the company where I'm working, every week I'm doing a training, development training, for the entire company. It's around 400 people are there. Out of that, around 150 technical people and other things, but everybody listens, or different type of. So what I'm trying to say is training is one of the most important things, and your procedures and your guidelines prepared for quality assurance, and then your material that also being checked, your specifications and checking and inspection. That is, this is one presentation I'm going to do it on Saturday for my company. How you check your materials, how you check your installations, how you check your process inside the factory. So what are the elements there? How you check it? Even if I ask what is actually the density of, see, the technical know-how, knowledge has to be enhanced. Always the engineers should know the basics. Otherwise, it cannot work. If you ask certain questions about the physical properties, what is moment of inertia, what is the density, or what is the components of this thing and what is Young's models, people will not say offhand. They have to refer something they must have heard about, but it is better always have to memorize these things. So that.
Anybody else?
So this is one, to conclude your question, what I suggest is these all three elements has to be focused: material, the process, the manufacturing, and the people. Those who are engaged. Then only you can get a complete product corrected.
Sir, yeah, thank you, sir. Thank you.
Thank you. Welcome.
Can I ask something about this
Yes.
quality? So we are having this problem of Palarivatam bridge failure.
Yes, yes.
That is not yet failed, but it is all with the suspicion of its quality.
Yes, it is. Of course, it is a quality problem.
Quality problem. So can you throw light on this aspect, taking this Palarivatam as an example, where engineering and design would have been certain quality assurance as well as quality control issues?
Yeah, like I mentioned, because it starts from the design assumptions what you make, because the engineer has to be competent and qualified enough to make his assumptions right. That is why our design basis of every project before we start, we create something called design basis. This design basis is actually being reviewed by a quality system, whether I'm considering the right kind of material or codes and standards. That is very, I have seen, I worked in India last year with the Geo. So a lot of projects they are doing, I was checking most of the documents. I always insist on the engineers making this. Where is your code reference? I changed the calculation format. When you do a calculation, you have to put your code reference. And if you want to overrule it, you have to give some references as well as justification for that. You don't, but many don't allow. You have to be within the code. Okay, that is one thing. Then your procedures, your computer analysis, which is done by somebody who is not maybe not experienced guy, because one wrong input can give you a complete wrong output. Like if you are making a design of a frame and you are releasing the joints, okay, it's not a fixed joint, it's a pin joint. You release it to pin, the entire behavior of the structure changes. The rotation is actually there, the translation is not, so how you understand it, where you do this. So kind of things, understanding of the engineering principles, very much essential for even using a computer program. The behavior, how it will behave. Even sometimes I ask, even you're doing a model and the printer, I said, get me a model, because I don't go in deep to the calculation. By looking at it, I ask them to draw the bending moment diagram and shear force. Then immediately I find out that there is a mistake. Then go and check your input so they can find, because presenting the behavior or understanding the behavior, you should have the sixth sense to find out. The third is actually the construction procedures, because established procedures are there, quality control systems very much, your material is to be checked, your process has to be checked, your everything has to be, there is a procedure, quality manual is prepared for a project. So if you don't follow all these things, results like this will happen. And it is costing 50 crore rupees is gone. Whose money is gone? Because this much of damage to the society. Sorry, the society as well, the state, we are all taxpayers actually paid that money. Somebody's mistake.
So
it's a purely engineering problem.
Yes.
So
you are suspecting or you are doubting about the deck slab, continuous deck slab system they adapted for this bridge.
I would like to add to it, Varghese sir, Rajendran sir. Basically, I mean, in addition to the designs, actually, the designs has been done by a very prominent engineer, actually, who have,
Bangalore, yes. I
yeah,
know.
who have designed a lot of big structures. And, you know, the contractor was also pretty good contractor. Actually, he's also a very well-established contractor. But, you know, to me, where it went wrong is actually, see, there is a government agency that was monitoring the system, the whole system. You know, some amount of money was allocated for this building, this structure, and most of it has gone through some other channels, and the rest was utilized for the construction, it seems. And for that amount, the quality of construction was, you know, supposed to be compromised. And there was a big argument here, and there was a lot of analysis which has taken place. A lot of structural engineers have analyzed the structure, and IIT Madras was involved in you know, the rehabilitation work, and they're pretty sure about the structure. They say that the structure can be rehabilitated, and it can be used for transportation. And you know, there was something that has been playing in between, and you know, there is a special interest for demolition, it seems. You know, in terms of structure and the strength of the structure, the senior engineers are very much sure about rehabilitation, and no, they say it can be made fit for transportation. So let us actually wait and you know, see what is going to happen. The taxpayers' money is already gone, and they want to spend more on this. And you know, that is where we don't get an idea of where we are heading to.
More than that, if you want to demolish it, how the entire road will be blocked?
Yes, already it is blocked since the last one and a half year.
When you start, the huge cranes has to come there and stand where, and then no traffic is possible.
And the best part of it is
only link between Vaitila and what you call
Edapalli.
There is no other link. And how many of you travel daily, live in Ernakulam and pass through that bridge? Pass through means you on the side, you know, you can see. I will just tell you a difference. There is another 2 bridges are constructed in Vaitila and Kundanur. So if you closely look at it, each span is actually the end girder is not continuous. It is 2 different girders in Palarivattam one, but the other one is continuous. There is no separation there. If you go next time, please note it. So the girders, actually the diaphragm which is supporting the main girders are 2 and 2 with an expansion joint. But in the other one, there is no expansion between. There is a single one, both the direction the girders are resting. If you next time you pass by, please look at it. So the Defect Ndt system is actually, I have done a little study before when I was there, you know, it is applied in that particular case. I don't know why it is applied in this case, because there is if you draw the bending moment diagram, you know, if it will work as a pin. So pin means your mid-span moment is actually much higher than if it's a fixed joint. You know, it will be a negative moment at the support. So that is reduced at the mid-span. So if you look at clearly, I have actually seen very closely the diagonal cracks, which is structural cracks. Yes. If it is bending cracks, it is diagonal. If it is shear, means it will be vertical. So things like that, people have observed it. It's why this kind of design assumptions, and that is what I said. Once before you make your design basis needs to be reviewed by another third party and see that your assumptions are correct. So you make a mistake in the design assumptions or your input, then you have it. You never do it. And then that becomes a standardization. You will not change. The government has to standardize a certain philosophy as a standard. So that is everywhere elsewhere in the world. It is when I still remember I was working with Aramco. There is a calculation format there. I just put all the values. I don't change the philosophy. It is the same philosophy they use. I cannot do any invention there. You know, my own inventions cannot work. So that is how things are being done. So this is something which, as Nembu said, there was a request that load test has to be conducted and see that what is the residual load it can take. If there is a reduction in the load, you can do a reduction, maybe very heavy things you can bypass through the bottom, or cars, small cars, scooters and small trucks can be allowed. So these could have saved a lot. Maybe another 5 years it could go 5 years, 10 years. Then you demolish. But now another building means not only waste of money, the disturbance it is going to cause to Cochin. That is the biggest thing.
Sir, one more doubt I have. See, you mentioned in the quality assurance
Yes.
that there is audit, quality audit.
Yes.
But in the case of Palarivatam, if we go for quality audit, we will go for the quality control audit or quality assurance audit.
No, you have to do the document which is actually prepared as quality assurance document in a quality manual.
Okay.
That needs to also be audited and see that where there's any mistake or not.
Yes, of course,
Because
that is correct.
The control team only look at the quality assurance document, conformity.
Yeah, that is true. That is true.
So it requires to be audited, the quality assurance manual also.
As well as quality control.
Exactly, both, yeah. Because these are not rocket science. Let me tell you, these are all everywhere, everybody is doing. It is not very complicated things. It's a procedure and a process, how you do it, and a determination of the agency who is implementing it. That is where the problem, if you are loose and if you are corruption there, everything can go upside down. Who cares? Even if you audited everything in book, it is correct. But what is have done at site, and I understand that there is no reports available. Quality control, daily quality control audit sheets, inspection sheets are missing, or maybe not there.
Yeah, the best part of it is actually, this has been constructed wherein a small roundabout would have served the purpose. See, that is the, weird facts. I've been, asking this question everywhere in all the forums wherein, big contractors are present and nobody has an answer for it. Why are we constructing such kind of complicated structures when we can, make it possible with a small investment? A kind of a roundabout. See, if you got, if you look at Gulf countries or the developed countries, you see a lot of planning, pre-planning, and that has not been done here. Well, we have a lot of young engineers here who want to express their views. I would request all of them, please come forward. A lot of them.
I have a request to all the young people. At least all young civil engineers should take a course on Qaqc.
Yes.
And quality management is something which you can get a job. Even an MTech structural will not get a job. A quality engineer will get a job.
Yes. Am I audible?
Yes, Mr.
Ravindra. Myself is Ravindra from Jammu. My question is, in the final product, we get two words. One is warranty and second is your guarantee. But in structural engineering, we replace such words with the structural safety certificates and structural audit. So structural safety certificate is issued by the structural engineer, whereas the job is executed at site by somebody else. How a man following all Qaqc and QA will give the structural safety certificate when it is executed by somebody else?
Yeah.
How he will know whether he has followed Qaqc or not?
Let me see that my company is a structural consultant. The structural safety certificate is issued after construction. He will do an investigation and of the entire thing, all the documentation like design, materials used, all those things, inspection is carried out. And now, according to the manual of Indian, I think it is, this thing is only valid for 5 years.
Exactly.
It is,
Exactly.
the certificate is valid only for 5 years.
Yeah, exactly.
You
Exactly.
cannot give a lifelong guarantee to something which you don't know. But how? That is why the quality system is in place to see documentation. I was stressing on that. Every activity or every process, you have to put a documentation in the file. What material you brought, what cement you have, what aggregate you have, what fine aggregate you have, what slump you had, what how long you cure it. Everything is actually that is what QA people do. They prepare a specification with templates. So the QC engineer go and document it so that later a structural engineer wants to go through this and assess it. He will have the documentation available with him, how they can carried out the job. Based on that, he can issue it.
But sir, should there be any provision that a structural engineer should also visit during the construction to see the all documents?
See, the problem is, we found this problem because they only give a job order for making the design, not for site visit.
Exactly, sir. Exactly.
And also the stability certificate that he gives initially is for his design, not the construction.
Not the construction. Exactly.
See, the problem, again, I raised this issue, and if you go through, the stability certificate should have some documentation inside that, some calculation. So I asked, when I was there, I used to ask this question to the newcomers coming for job: what is the stability of a structure? What is restoring moment? What is overturning moment? They don't know.
No, exactly.
So this is what the stability is basically, and they don't have any idea. Instead, you are putting a high-rise building just like a tube. And if it's a lateral load is there, then it will be unstable due to a overturning moment. What is holding it down? So understand that the problem is nowadays the engineers are not, or the basics are not very clear.
Exactly.
That is what basically I observed there. All this they come, but it takes some time to get that orientation, maybe a year, for a guy to get some kind of orientation. Why I am doing it? What is for I am doing it? What is the objective? All these things. So it is a problem of the quality of engineers also is there. Not understanding, they make, that's what I said. When you make a drawing, the third check is actually the content of the design should be checked. What is actually the content, the number of bars, number of, spacer, whatever is the size of the beam, everything has to be mentioned because that is the design output. So you have to check that. So, I mean, there is a process. This is a process.
Sir, most of the engineers don't know about the BBS.
Yeah.
Sir, if you allow me, I would like to add to this subject.
Please go ahead. Please go ahead.
Yeah, my name is Prakash Bhatt. I am from Pune, Maharashtra. Nowadays, what practice is adopted over here, structural consultants issue stability certificate only after receiving project manager's certificate related to quality of material and standard procedures adopted. That undertaking is needed to be submitted by project managers of the construction site, and then only structural consultants issue their stability certificate, though it is specifically to their design stability, but they issue only after this certificate is received.
Yeah,
that is general practice what is adopted nowadays.
If I want to issue a certificate, I will definitely ask your supporting document.
That's true. That is to be submitted by project managers now.
Exactly. You cannot just simply give a certificate for issuing a stability certificate. What is the basis? Give me the supporting document. How you can say that it is you have done all this? Where is your Qaqc or design documents or your construction audits and things like? all those things required to be submitted along with your project manager certificate. Otherwise, you cannot make an
Yes, sir.
assessment.
Yes, sir. I take this opportunity to thank you for excellent presentation, sir.
Thank
We
you very
got
much.
so many things to learn out of it.
You will attend maybe many more in the coming weeks.
Yes. Thank you, Mr. Prakash. Please
Yes,
be in
yes,
touch.
yes.
Please stay in touch. We'll be informing you
Hello.
of the coming
Definitely.
sessions also. Yes,
Hello,
Pranali, go
sir.
ahead.
Am I audible?
Definitely, sir.
Yes,
Yes.
Pranali, go ahead.
Yeah. Hi. Hello, everyone. Hello, sir.
Hi.
Sir, actually, I'm working in a private firm, and QA and QC is a very vital part of our firm, and it is continuously evolving and continuously improving at every stage of construction. So, actually, my question is to you as well as to everyone in the panel. Uh, this QA and QC, is it given equally importance in the projects which are undertaken by the governments, cause government agencies or under the government programs? Because I can see that in a past 1 month there are two bridges which got washed away before the inauguration period, one in Bihar and one in Madhya Pradesh. So I just wanted to raise this question because every year there is a lot of budget is being allocated to the infrastructure part by the government. So my question is, after investing so much, before the functionality of that structures even being used by the public, which is meant for the use, it gets vanished away. So my question is like that. It means it is not just respect to the bridges, but it is also with respect to the flyovers and all, which is being carried out by the government agencies.
See, the point is that recently there was one similar bridge under construction washed away in Wayanad or somewhere. Now the girders fell down. So the main question I would say that who will build the cat? The government agencies they don't have any commitment like earlier, because there are so many engineers, departments work there. Now the commitment, everything is gone. Every department is not functioning as the way it should be, from the design, from finding out, or maybe even awarding a design contract to a consultant onwards. Material suppliers, construction companies, and then the way they are construction methodology, method statements, your time to time, your Qaqc. Daily one team has to be there. A complete team testing every material. There are two ways. One is material quality, one is construction quality. Both you have to test at site. And if you find that there are materials are substandard according to the specification, you recommend for a test, not an inspection. You ask them to go and test it again. Your reinforcement, maybe it is, normally it is actually with a stamped, your grade and other things and things. But sometimes you don't find it rusted, you have a doubt. Grade 500 and they bring 425, you will know what is the difference it will create in the behavior, the life. So it depends on the project manager, the strong team which are now manipulated by the government agencies. This is the problem what is happening in India. So we are so sad sitting and that is why around more than 35 years I worked abroad. We never had this kind of control on project by start from day one. And I used to attend meetings with the clients or contractors. Two things what they ask. First, they ask QAQC. Second is HSE. These are the main topics they discuss on. I mean, QAQC is that important. Everything what you have on paper, if you don't implement it properly, there's no point. Or maybe you have this. So I appreciate you being a young engineer, to highlight this, or maybe you can start raising your voice and tell the people around you, or maybe this fraternity in any forum, that you should be a member of the Institution of Engineers or something like that. You can go and present you can raise your voice. So this is the way, but If you
That's the potential. That's the real potential of this group. Actually, I'm
exactly.
so fortunate to have such enthusiastic engineers in this group, like youngsters like Runali, and all of them are actually coming forward, to express their views. And this becomes our duty to raise
Yes.
our voice. It becomes our duty.
You should not lose
India.
your curiosity, and if you are working, you put your head, heart, and hands on it.
Yes,
That is how you
absolutely.
should succeed.
I have,
Yes.
Yeah, Mr. Giri, go ahead.
Sir,
yeah, I have a
I want to
question.
say
What is the
something.
best way to motivate the team regarding the quality, maintenance of the quality?
Yes, come again. I mean, your
No,
voice.
motivational factor
Oh,
at the
yes.
sites.
So, see, engineering is not doing under company. It should be a passion. See, I
Correct.
consider that way, because you should have certain kind of responsibility and commitment to what you are doing. Because any mistake you do it as an engineer, it's a loss to the society. Basically, something goes wrong, a bridge is collapsed. It's a waste, or maybe you are really not committed to your surrounding, because engineer is not alone enjoying your benefits. Your mistake is actually suffered by your entire community. So that kind of responsibility you have to feel. At the same time, you should have a passion to read and study every day. There is always some room for improvement. That is the next presentation. We will have that continuous improvement in quality. So that we'll talk about that. But anyway, this is the motive. What we see right now, engineers are only looking for whether they can get a job, they can get some monthly salary. That won't work. That won't be sustainable for a long time, because you have to come with innovations. I was sometimes asking interview question like, why the I section is an I section? Why it is?
Sir, I have something.
Yeah, Himanshu.
Sir, you sir, nice presentation firstly, and
Okay,
my
thank you.
sir. Sir, about what the concern about the recent, washing away of 2 of the bridges. My point is only one, sir. When we plan for something, there's something called as a hydraulic data. Correct me if I'm wrong, sir. But then that hydraulic data clearly mentions the highest flood levels over a period of time, or maybe 50 to 70 years. It covers everything. So when we are planning for all these things, we have to study the hydraulic data correctly. That is one. And concretize my point, you will see that whatever bridges that the British engineers had planned for the railways, none of them have kuch nahi hua unko. You see first of the flood.
I was in Allahabad. There is a Yamuna bridge which is upper. It is a train, railway, and the bottom is actually it is constructed maybe 100 years old. Or maybe we have Cochin also. There is 2-3 bridges which is more than 160 years old.
Nagambaram Bridge, which they tried to demolish.
I was part of. Having seen a lot of Northeast. We used to come from Tripura to Siliguri, and there was one bridge which was constructed during World War II. It was used both for the train as well as the road. When train used to come, the traffic used to be stopped, and that kind of, and we are still using it. Quite recently, we got connected to Agartala. That is a different way. And you see the older bridge of Guwahati, sir, over Brahmaputra, it is a 2-tier bridge, sir. It is for road as well as for the trains. So something where what I'm trying to say with washing away of all these points, coming to back to the point is that, sir, that we have to study things correctly, whatever data is available. Otherwise, these kind of repetitions will keep happening.
See, the point here is like there is one more thing I would like to add what I said. Why the quality assurance and quality system actually evolved in today's time. If you look at the design process methodologies, what we used in structural engineering, we used to do working stress method, till say 20, 30, 40 years before. Then we changed to ultimate load and plastic. So we try to test the limit of the material used, the stress maximum limit. So then what we found that unless and until if you don't check your what you call stresses, your behavior, other things correctly, it will fail. The working stress method is having around maybe 30% factor of safety because it will not yield. That is what the ultimate load is. So you don't need, even if you don't have, if you have an external additional pressure or a stress, it will not fail because it can contain. But the one which right now you are doing is, still they go for plastic design or ultimate load, because it is about 95% of the limit you are checking. You are loading up to 95%. If your quality is not maintained, it will collapse. And plus, another thing is all this implementation requires determination, commitment, and willingness that this is something common for the people. That kind of thinking has to be there with the leaders as well as the engineers also. Maybe they are, I don't know how much reliable they are, how much committed they are, how much truthful they are. Is also there. Maybe their knowledge is questioned, but their commitment may be questioned sometimes.
So what is railways following, sir? What is the methodology railways is following? Because their structure
Railway has a lot of their own IRC specifications and codes and standard. They are very stringent in quality control and quality because it is a matter of life and death, and railway will never compromise. That's why we want a company to pre-qualify to do a work for railways. It's not an easy task. So that system is not there in the PWD that I always call public waste department. It is always called like that. So they don't have any commitment to the public. Railway is not like that. Even though our railway is not in comparison with the railways abroad, people travel at 300, 350 kilometers per hour. So, but here still we are struggling to achieve 150, it's very difficult. But anyway, the commitment, quality system, quality assurance is one of the major things now the engineer should focus on. You need to do a master's or diploma or anything which you can get a job also. And your implementation of your project, how it is done, you get a satisfaction as well. Oh, this is done better.
Right. Thank you so much. Anybody else? Anybody else from the?
Varghese sir, it was very elaborate and you connected well with the quality and cost factor also. My question is very small question, but I was every time I wanted to issue NCR. So is there any frequency set to issue NCR in the project?
No, non-conformity is actually found the reject or mistakes or maybe defects in conformity with your established procedure you should follow. So what is actually the NCR is getting means you are doing not a good job. The number of NCRs you receive recently, I asked the head of quality one project. I asked him how many NCR internally you issued. He said 2 NCRs. I asked that quality person that how many NCR you issued. He said 2 NCRs I issued. And how many NCR you got from the client QC? He said 4. Then I said, you are lucky that I would have been better in the other way. Means you are not checking properly inside. So NCR is actually non-conformity is against the specification and requirements. So if you find non-conformity, you will NCR. Means you are getting more NCR means you are not doing a good job. Simple as that.
For repeated mistakes, if he repeatedly gives NCR, so what is the next stage after NCR, repeated NCRs?
Yeah, you will do a corrective action.
Corrective.
So yeah, so once you receive your NCR, your department will see that what can be proposed to do a corrective action. That is approved by the management because it may cost money. Additional cost will be there to correct it. And it will not be good for your quality of your client will have a bad mark on you that you are doing something and your project will be delayed, your component will be delayed, something like that. So it is always better to keep very strict control on your manufacturing or process or construction right from day one. NCR is actually closed with the corrective that you have to prepare it, submit it, and they will approve it, and then they will ask to perform it or maybe to execute it.
Thank you, sir.
No, maybe you are not. He has not given the question properly. I understood his question. A contractor is doing a repeated mistake on the same NCR. Is that the question?
Yeah. Yes, sir.
Yeah.
Correct.
So there is a mechanism you can deal with that. The only language the contractor understands is the money. So link this closure of NCR with your billing cycle. At the end of the bill, along with the bill, your NCR status report also should be attached. So if any NCR is not closed within 30 days, I'm giving for example, you can fix your own time as per contract. If the contract is not telling any time, you can fix your own time, maybe 28 days, 4 weeks. If any NCR is not closed from 28 days, if it is raised, then you can withhold the payment as the quality engineer decides, or payment related to that particular quantity of work or particular area. You deduct that money, then once it is released, the NCR is closed, then the following billing cycle, you can release that amount. So this is the only language a contractor understands. I have been practicing for many years. It works out very successfully. So you have to bring it into the system. And have I answered your question?
Yes, sir.
Yeah, the point is this kind of condition should be mentioned in the contract at the beginning. Your quality policy or maybe the quality document should spell out when you issue this to the contractor. Otherwise, he will not do it, because how do you control? He is obliged, he signed a contract with you accepting this provisions.
Yeah, the FIDIC says within reasonable time. Reasonable time, the project manager can decide.
What I mean to say is the Qaqc department has to issue and prepare a document in advance. In the beginning itself, that putting this, if you don't close the NCR corrective action, you will be deducted. We'll ask somebody else to do it. Whatever money is actually incurred for that corrective action will be deducted from this people. So something like that.
Thank you, sir.
Thank you so much.
And Himanshu was asking a question, how the railways is dealing with that. I have worked with the highways department. I have experienced it many times. When you travel in a road which is parallel to your railway track, and when you come across a small bridge, a culvert, in the highways department, they make a culvert. But you look at the left side and right side, you'll see a big bridge built in stone some 70 years before by British people. Because the hydraulic particulars, hydraulic data, every water stream has a hydraulic data. We have hydraulic data from 1885 onwards. So with that, railways takes 100 years data to build any water body bridge. So they sustain any maximum flood condition. But highways cannot do it, because highways cost is very less, and then the replacement cost if we take, railways is very high. We cannot make a diversion for railway track. And highways, you can always make a small diversion and then repair this culvert, even if it is washed away. So that is why you will see a lot of difference between the same CD work. It is called cross drainage work. Between CD work by railways, CD work by highways. It's totally two different. Highways takes only 10 years flood data, high flood data, whereas railways takes 50 years or 60 years or even 100 years data. That is why you see this difference. And number 3, the girl was asking a question: why is the government putting interest in
QA/QC, are they really serious about it or not? I feel I have a different way of answering this question because I come from one of the government department. See, India is producing 15 lakh engineers per year. If you take in 10%, at least 1.5 lakh civil engineers every year we are producing, and India have produced finest engineers who are serving is in Gulf. The standing testimony is Mr. Varghese himself. So like this, there are many engineers India has produced within, they are serving within India, outside India. The problem is the corruption factor. Many of the good engineers in the departments, they are incapacitated by this corruption factor. When such circumstances, an engineer takes two decisions, two mistakes I can say. One, succumb to the corruption condition and sustain there and keep quiet.
True.
And number two, what I did, run away from the scene. So I ran away after 5 years and 6 days. I ran away from the scene. So please don't do the same mistake, young engineers. My request, my humble request to young engineers, don't do the same mistakes what we have been doing. Fight back, fight back, fight back. So
Very
this is
true.
the
It's a
only way. And I thought I am the only person. If I run away, this government is not going to lose big, and I'm not going to change the world. I'm not here to going to change the world and all. But if every engineer thinks in the same way, we can change it. So my humble request is don't bend from your principles, because bending is always a serious problem in civil engineering. When you grow and get into the industry field, never bend from your principles.
That's a very, very, very good, very good opinion and a very good suggestion from a very senior engineer. The youngsters have to stick to their policies. They should have that principle, and they have to set it up during their initial phase of life itself. Thank you so much, Shivraman, for that wonderful, advice. On behalf of this whole group, I would thank you for that. Yes, before actually, Arun Lal has a question.
One thing is coming to our mind, sir. Shivraman sir, thank you so much. You got a very good point, sir. There was one during 71 war. We were to cross, and go. So the bridge classification was not permitting the kind of vehicles that were to cross. So one of the army leaders, he said, okay, the bridge is built by the British engineers, and the factor of safety is good enough to take the load. So they finally crossed, and we could finally. So that is the kind of planning they did. They had a lot of planning, better planning things to do. So that was just what was coming to my mind. Sorry to the neighbor, please.
Thank you, sir. Thank you, Himanshu. Well, before I move on to Arun Lal, actually, Arun Lal, one thing actually, see, instead of this platform is different. You can always come in and ask anything. Doesn't matter, whether it's a very relevant question or anything. You can always step in, ask your concerns. Arun Lal, before I come back to you, I would like to go to Janani. She wanted to say something.
Thanks, Lord Varghese, sir. That was a wonderful presentation. I just want to ask one question. Like you have a good experience, like in oil and gas. Yeah. So can you give us an insight about how did you implement QA/QC in that particular?
Sorry, I couldn't hear it properly. Because
how do you implement? How do you implement QA/QC?
Like how challenging it was while implementing QA/QC in oil and gas sector. That is my question number one. Also,
okay.
Question number two is like it is little basic. That is like how is QFD? How is QFD related to Six Sigma belt? Like that too.
Well, two questions actually. One was how challenging was it while implementing QA/QC in oil and gas? And the second question is, how is it related with Six Sigma?
How is QFD, quality function deployment process, is related to Six Sigma? Is it one of the tools? Is it one of the approaches of the Six Sigma belt tool, or is it different?
Yes, the oil and gas is the one which is an energy sector and very hazardous in nature, because all the facilities are constructed with very stringent specifications. Very, because the hazard involved in the installations are not like normal. It can give a lot of problems. That's why quality systems and quality procedures are very, very high in oil and gas, but there is no compromise. And if the department is well staffed, well equipped, all the best equipment to measure, detect everything, because if you go to a process area, you will have a hydrogen sulfide. How many ppm is there? If it is more than 10,000, people will die, because these are all hazardous area. Specification has to be controlled very strictly. So from day one, from the design stage itself, that's why they conduct something called HAZOP study and this thing, hazardous area classification. They will check all the process is actually being checked and verified and conformity with mostly all the standards are American.
Like APC hazard rules.
This is all API. American Petroleum Institute is actually, because we don't have much of, all over the world that they use this American standards for that. Very, very stringent. So it is not very easy. It is very challenging in oil and gas, and no compromise. If there is any mistake is found, he is fired next day. There is no limit. That is how action is taken. So conformity, commitment, and get into the project. That is very important. It's not that they start big documents, they have to read it and learn by heart. They walk around in the plant, maybe it is 1 kilometer, 2 kilometer long. Work is going on, and then he's moving around and seeing all things happening. So it's not very simple. And when you have your second question, quality function deployment, that is a philosophy or maybe a tool which is converting your idea into engineering terms. Because some idea, if you have to implement it or you create it, like I made an example, like you are going to an architect, you want to build a house. So you tell the architect that I want a house with 3 bedrooms and then this is my budget. So the architect converts that idea into a drawing or an engineering format. So that an engineering format, why they do it, it is presentable, and then you can do an estimate. If your components are identified, you can do an estimate. So that it will come that your budget is within the budget or your requirements are going to meet. So this particular tool is used to convert any kind of idea into an engineering format.
Right, thank you.
One more thing, like in QFD process, we have this terminology called house of quality, right?
Sorry, I couldn't.
In QFD process, there is a terminology called house of quality, right?
House of
quality.
Yes, okay.
So how is it more similar to, is it related to Six Sigma build tool process, or is the approach is?
No, Six Sigma is actually your elimination of defects.
Okay.
Elimination, that Six Sigma, Sigma is actually a statistical word. Statistics, because 1 sigma, 2 sigma, 3 sigma, 6 sigma. So 6 sigma is 99.99993. And the 3 sigma is 99.9, something like that. This is a bell-mouth, statistical approach. You can calculate what is actually the standard deviation. So you can find out what is a limit as per when you do 6 sigma. So and then now it is actually added with lean, elimination of waste. So elimination of waste plus elimination of defects. Now,
is QFD process is different from like the approach to what we do to Sigma, or
the QAP is a quality assurance plan.
QFD or QFD.
QS,
Is QFD is quality is QFD process is more similar to Six Sigma build approach, or it is different?
no, Six Sigma is a tool.
Yeah.
it's a tool, because you apply that and find out the defects, and then you do a kind of remedy or maybe your rectification. So here you are studying, the process is being studied. You studied, that is a tool applied to eliminate, how you can eliminate that defect.
All right, thank you.
And we will come in next, maybe not next one, the next one we will do Six Sigma, Lean, Kanban, 5S, value stream mapping, all that we will do a session. So
in the upcoming sessions, we can discuss all that. Thank you so much. Thank you so much. Thank you, Janani. Well, before we wind up, I would like to give Arun Lal also a chance to ask his question. Arun, please come.
Hi, good evening, sir. Sir, my question is, in nowadays in Kerala, most of the government works are carried out by work together with many agencies, government agencies itself. So how can we implement this QAQC activities in these conditions?
See, QAQC is actually a part of the management system. Like once you develop the project document, you have to establish the requirement of QAQC in that. There's quality manual has to be introduced and quality scope of work has to be introduced. You have to list out what is required, what level of quality is required for this particular. So you make a kind of document as part of your scope of work, because quality will not come cheap, because the contractor has to make some budget for operating a quality system, because it will involve people, it will involve machines, it may be involving so many things. It will not be cheap. But the advantage of quality system is for the user in the long run. See, like if you take the example of our Palarivattam bridge, we don't have a quality, but it is paying back. I don't know whether they had money or somebody didn't use it. So we are, after 2 years, we are suffering. So to avoid this, you have to have a scope of work, a quality manual, your quality specifications, and quality systems in place while bidding, while doing the tendering. Otherwise, nobody will just bring quality for anything if they are not asked to do it.
Well, which means during the design phase itself, the planning phase itself, actually, we need to have a quality manual.
Sir, one more thing I have to add to it about this Palarivattam case, because I am also have some knowledge about that matter, because I am working with Qaqc on that time. And I am also near, not in that Palarivattam bridge, near to that one project is there for Qaqc. And I have to say that Qaqc has very good QAQC plans also. But due to some other, I mean, there are so many other agencies in that project also. Some due to that reasons, because of the Qaqc has some limitations to implement their own QAQC plannings. I mean, fully to this project. I think that may cause this problem.
Since it's a government-run organization, there are many factors that could influence all their actions.
But that is not an excuse,
That
because
is not an excuse. Yes,
because
and I believe that along with the verdict, along with the Supreme Court verdict, they should have issued a verdict to put all those guys behind the bars. Whoever has given the approval for this.
Because that commitment, because the Qaqc is actually, I think, one of the main culprits in resulting this poor quality of work, because they were, the chief of superintending engineer level, retired guy, I don't know what his name.
Yes, sir.
Is the project manager or somebody was behind bar, for some time, because the culture of PWD doesn't work in projects. Believe me, that is gone, and that is only good for making a small fraud or a small thing, something like it doesn't involve any risk involved. Because definitely in such projects, what happened in what I was involved, during the project development, It's not design alone. Project development, that is the basic project, development stage, the basic engineering stage or conceptual engineering stage. Okay, you establish a design basis. What all things you will consider in design? What all things you will consider in this thing? Then you go for a value engineering exercise. All what you have considered is right or wrong or something missing, something should be overlooked. This is what value engineering is. You define your requirement precisely, what is required, what is not required. But because something excess is also a cost. Something less is actually a tragedy like this. So you have to avoid all these things. And then the problem is how much importance you give as a senior man who is actually controlling, like he is a manager. Like I said, his administrative authority he has, he is controlling the entire department. He is a manager. He is not a leader. You know, he is not doing the leadership quality. He is not all managers there.
Yeah.
So you do something which is no commitment. It is only for whitewashing the authorities and say that something. And what I heard was there was no file also, daily Qaqc inspection report files were missing.
Yes.
So how do you, there is material quality, material inspection, when before you material quality check and testing is done for random, that is the code specifies if you bring more than this much quantity, how many number of specimens you will take and do the test. Make sure that what you are doing is, the work is actually according to the quality requirement for a safe, it's all safety, yeah? Safety and durability. As a structural engineer, what you are important is your strength, your stability, and serviceability. These are the three parameters a structural engineer is always looking for: strength, stability, and serviceability. Means life. So these are you don't compromise on that, whatever happens. So there is a lot of things. The system is actually wrong from day one.
Yeah, the system is actually the culprit. Basically, it's very easy to put it on the engineers and escape.
Unfortunately, even as a state like Kerala, we have a lot of talents available in the
Very
state.
true.
But
Yes.
it is not.
And especially in Cochin, we have a lot of talents.
Yeah, plenty of talents. See, I used to feel ashamed when you open the Chinese infrastructure, the bridges and all they are making. You can't even imagine something like that is actually possible to construct it. And this is not a rocket science. It's this is not a new thing. The bridges we made bridges from ages, more than 100 years. The philosophy is available with us. The knowledge is available. The engineering is available with us. It's not new. Maybe the little change, like what I said, working stress has actually been changed to ultimate or plastic or deck continuity. See, all over America, US, it's all bridges and deck continuity system. There is no failure. So it is possible everywhere elsewhere, and why this is our problem. We have to identify that and see, and it is once you politicized it,
Yeah,
then it is gone. That is a problem what we have.
And the politicians can just put it on the engineers because we don't have an engineer's bill.
No, yeah, that is another. And one day maybe they will claim they will send rockets to moon, the politicians.
Yes. Yes, well, and the funny part is a person, an engineer, a senior engineer from PWD approached us asking us, what is the continuity? that's the funniest part of it. Anyway, it's time for us to wind it up. So thank you so much, Varghese, for this enlightening session. We learned a lot. Thank you all the participants for being so attentive. And I've been urging everybody to stick on till the end, and I've been telling them the best part is at the end of the session. Anyway, thank you so much, and thank you. Take care till we meet the next session. Thank you, and good night to all.
Okay, thank you, Varghese sir. Thank you. Good night.
Thank you very much.